This is y log number 37, and we're going to be going over exponents, the product rule. Now you have x cubed times x to the 8th. The product rule is that if you have the same basis of x, if you have the same basis, in this case it's x, you can add the exponents together. So in this case, x cubed times x to the 8th power is the same thing, here we go, as x cubed plus 8, which is x to the 11th power. If I were to actually demonstrate this, it would be as follows. X times x times x, and this little dot means multiplication. Now, you have 3x's for x cubed, now times x 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 times x. And now there are 1, 2, 3, 4, 5, 6, 7, 8 x's on here. Now, if we were to multiply all of these together, what would we get? Well, we would get the exact amount, x to the 11th. And that's basically the product rule. Moving on. Now we have exponents quotient rule. In this scenario, x to the 5th, if you have the same base, you can subtract the exponents. X to the 5th divided by x to the cube is going to be x5 minus 3, which is going to be x squared. Now, if you want to demonstrate this, we can do 5 x's on top and 3 x's on bottom. Cross them out, and we only get x squared as our final answer, which is the exact same amount as we got from the quotient rule. So in general, whenever you see product rule, when you're multiplying the same bases with different exponents, uh, excuse me, if you have the same bases, then you can add the exponents together. Quotient rule is the opposite. If you can divide them and they have the same bases, you can subtract the exponents. And this is only applying to the exponents, not the bases. The bases have to be the same. Okay, moving on. Now you have zero exponent rule. Now there comes a situation where we get this, where the exponent is actually just 0. What that means, no matter what, the result would be 1. Y to the 0th power is just 1. So, for example, if I were to do this really complicated thing, it is super long and it's difficult, and then I see this, that all of this is to the 0th power, well then I just know that the result is 1. That is the zero exponent rule. No matter how complex it looks, if it's to the 0th power, it's just 1. Moving on. Now it's asking us to expand the following functions. Well, that's just distributing. In this case, 2a cubed is 2a times 2a times 2a. 2 times 2 times 2, well, that's just 8. A times 8, a times a times 8, well, that's just a cubed. That's our answer. Moving on, you have x squared over y to the 4th power. Well, x squared times 4 over y to the 4th power. X squared to the 4th power is just x squared times x squared times x squared times x squared over y 4th. Now you just add all of these together and you get x2 plus 2 plus 2 plus 2, y to the 4th. You get x8 over y to the 4th. Now, you can see that if you just multiply 2 times 4, you get the same answer. But our result is x to the 8th over y to the 4th. Now, solve the negative exponents. Whenever we have negative exponents, so there's a negative here, all that means is that it's just going to be the reciprocal of the actual number. So if x to the negative 3, then we can just say it's 1 over x to the cube. That would be our actual answer. Moving, let's see. Let's try this. 4 to the negative 2, right? Well, then our answer is 1 to the 16th. Since whenever you see this negative, you can just find the reciprocal of the number if there wasn't a negative. So if there was no negative here, then it would just be 4 squared, which is just 16. Because there is a negative over here, we just find the reciprocal of this number, which is 1 over 16. That is it for Wylog number 37.